Hello students, with the previous lecture regarding vernier caliper and micrometer, we have seen the vernier caliper and now we'll be continuing with a micrometer. Myself B. Megasham Raju, Assistant Professor, Mechanical Department, Engineering College, Bikaner. So, we have seen what are the different types of vernier calipers and how the advancement in the vernier caliper happened through dial gauge and electronic digital caliper. Now we'll see much more advanced instrument which is called as micrometer. So this is where in the diagram A you can see the micrometer. So this is what the micrometer, and this is where the vernier caliper is. Let me compare why we are going for the micrometer. Before that, we know that micro in the sense which is an 1/10th part of an millimeter, and the second meaning is handheld measuring instrument using a screw based mechanism, right? So this micrometer first invented by a Greek mathematician called William, used in telescope to measure angular distance between stars. So why we are going for a micrometer? This micrometer can provide a better least count and accuracy when compared to an vernier caliper. Why? Because here you can see that the line of measurement of the instrument and axis of the instrument here both are coinciding in micrometer, in which in the vernier caliper it doesn't coincide. The line of measurement of the job and the instrument are at an different heights, right? Because of this there is an higher chances of error, which is nothing but lack of accuracy. So this is better explained by an Abbe's principle, which is nothing but maximum accuracy may be obtained only when the standard is in line with the axis of the part being measured. What he is actually telling is, for example, if you just see the vernier caliper, okay, here the jaws and the job having sorry here the job and the jaws should be firmly fixed with 90 degrees in an action. If there is an variation in that angle, then the measurement won't be perfect. Okay, why there will be an variation in the angle is, while using the jobs, while fixing and removing the jobs, the wear and tear will be happening in this jaws or in the beam, which will result in an angled fixing of the job. Here you can see a certain amount of angular error marked as X will always be present. This angular error also depends on how far the line of measurement is from the axis of the instrument. Obviously, if the line of measurement increases, if this h distance increases, then obviously the angular error will also increase, which will again result in loss of the accuracy. So to avoid all this, there is another instrument which is nothing but micrometer, where the line of measurement and axis of the instrument will be coinciding and the angular errors will not be appearing here, right? Now let us discuss outside micrometer. So the outside micrometer structure will be like this. It consists of an C-shaped frame. It consists of an C-shaped frame with stationary anvil face and an movable spindle face. Movable spindle face. The spindle movement happens with a ground screw. A graduated scale is engraved A graduated scale is engraved on the stationary sleeve and the rotating thimble, which is nothing but here you can see the scale over the sleeve and the thimble are there. This lock nut is provided to firmly hold the job and to restrict the movement of the spindle, and the ratchet is provided so that you will get a feel of the pressure, how much pressure you are applying over the job. If the job is placed in between spindle face and anvil face, you will get a feel of how much pressure you are applying over the job, so that you can avoid the over pressure, applying an over pressure over this job. The range of the micrometer varies from 0 to 25, 25 to 50 or 0 to 50 mm, and the maximum range is limited to 500 mm only. Generally, if you compare with a vernier scale, this sleeve graduations is considered as a main scale in this micrometer. Let us consider one example as shown here. The smallest division on the scale reads 0.5 mm. Okay. On this scale, the smallest reading represents 0.5 mm. If there is a movement in the thimble, the spindle forwards by 0.5 mm. Suppose over this thimble there are 50 divisions in which one division represents 0.5, so the least count of this micrometer will be 0.01 mm. If you just place a job in between anvil face and a spindle face and the readings are like this, then here you can see the main scale is having an 8.5 mm after 5, 6, 7, 8 and 0.5. So 8.5 mm over the sleeve, which is nothing but a main scale reading. Now already we know that the least count of this micrometer is 0.01 mm, and now if you just see 20, 21, 22, it coincides with the main scale at 22 reading. So it has to be multiplied with the least count 0.01, which will be giving 8.72 mm. So it is very easy to capture the reading when you place a job in between spindle face and anvil face over this micrometer when you compare with the vernier caliper. But the main disadvantage of this micrometer is the range is very less. Vernier caliper is having huge range. That is the only problem with this micrometer. Apart from that, here the parallax error won't be there, and whatever the spindle and the anvil face are made with an cast iron. Even a mixture of an tungsten will also be there, so that wear and tear will be very less when you compare with a vernier caliper. The angle error can also be eliminated with this micrometer, and the only disadvantage is range. That's all.